Ladies and gentlemen, welcome, and thank you for joining today's Annex 4 Environmental Research Webinar Series, Tools and Resources for Environmental Assessments. Please note that all participant lines will be in a listen-only mode throughout the call. You are welcome to submit written questions during the presentation, and these will be addressed during the Q&A. To send a note, select All Panelists on the Send To drop-down menu of the chat panel located on the lower right-hand side of your screen. And if you require any technical assistance, please send a note to the event producer. With that, I'll turn things over to Simon Gearloss, Project Manager from Pacific Northwest National Laboratory. Simon, please go ahead.
Thanks, Jordan, and thank you all for being here today. As Jordan mentioned, you're in the right place if you're attending the Annex 4 Environmental Research Webinar Series. This particular webinar is addressing 3 different tools and different resources for environmental assessment for marine renewable energy. So the tools we'll be discussing today, we have 3 excellent speakers. The first tool is a tool called RADMAPP, which supports siting decisions for marine renewable energy development. And Duncan Clark, who's head of GIS and data management for Aquaterra Limited, will present that tool. The second is Impact, which identifies potential impacts, provides guidance on how to address impacts in consenting and permitting processes. And Ian Hutchison, also from Aquaterra Limited, will present on that. And finally, Dr. Andrea Copping from Pacific Northwest National Laboratory will present a tool in development called Management Measures, which is a way to organize and document different solution sets for managing potential environmental risks. So all 3 of these tools are designed to reduce the risk and improve the efficiency for environmental consenting and permitting processes. These are all aimed at different audiences, but a broad set of audiences, including developers, regulators, and other stakeholders who are interested in the process. And it's very important to note that none of these tools are intended to be prescriptive. They're simply resources to help all of you working in this space move process forward and support informed decisions and discussions. So the way we're going to do this webinar today is I'm going to go ahead and introduce the first speaker, Duncan Clark. Duncan will present, and then he will introduce the next speaker, Ian Hutchison, who will then introduce Andrea Copping. As Jordan mentioned, we're going to have questions and answers here, but we're going to wait till the very end to do it. So as you're listening to each presentation, please do be proactive and go ahead and put your question into the chat box as Jordan described. I will be organizing and collecting those different questions, and when we get to the end, we'll go ahead and ask the panelists what those questions are. So please do be proactive on that so we don't get to the end and have a blank discussion session. So with that, I'm going to go ahead and introduce Duncan Clark. Duncan is the head of GIS and data management for Aquaterra. He joined Aquaterra in 2003 after graduating from the University of Liverpool. Duncan specializes in data manipulation and management, as well as a wide understanding of marine environmental processes. He's been a core team member in the development of Aquaterra's data management tools and its marine surveying activities, and has been heavily involved with the development of Aquaterra's in-house RADMAPP tool. So with that, I just somehow lost the webinar screen, so hold on one second here. Jordan, would you mind switching to Duncan? My webinar just went blank on my screen.
No problem at all. Duncan, you should have the presenting rights now.
Thank you.
Yeah, I can see I've got presentation rights now. So thanks for the introduction, Simon. So as discussed, I'll be talking through the RADMAPP tool. So just before we start on the tool, I've got a couple of slides just to introduce Aquaterra as a company. So Aquaterra was formed back in 2000 with a background based in the oil and gas sector. One of Aquaterra's main aims was to provide intuitive and alternative ways of presenting information alongside or sometimes even instead of a standard paper report. We're a company that offers full life cycle support from strategic planning right through to site-specific individual projects and technology support. We offer full life cycle support, as I said, and to date we've worked on 50 marine renewable projects for 20 different clients, and some level of involvement with almost every marine renewable technology at prototype stage. We've got a fairly small team, but provide an expanded range of expertise and skills through collaboration, working with a large group of associates and core delivery partners. And one of our key partners, you can see at the bottom there, is Ocean Pixel, based in Singapore, and we'll come back to them later on in the presentation. So the site selection tool I was talking about, it's not been developed with one area or one technology in mind. Instead, the principles and values used to find the best site for a technology or to find the best technology for a site are created that can be utilised anywhere around the globe. And these underlying principles are constant within the tools that we'll be discussing today. So the work we carry out here looks at both the effects development will have upon the environment, but also the effects the environment could have on a development. And there's no point in just saying a development is fine to be located here, because no impacts will arise from it if the development can't stand up to the elements. So why is there a need for geospatial analysis? As you can see on the slide there, picking the right location is key. There's a lot of growing information about sensitivities. The seas are getting more crowded. And as I said in other presentations about site selection, that location is key. It's an imperative that a development is located in the right part of the world, not only in terms of the raw resource, but it's also in terms of a market. The politics in that country suited to development, is the demand for the product, is the existing infrastructure capable of coping with the development. And within a country, where's the resource greatest, is a suitable supply chain to make the development happen. Then once a suitable area has been chosen, where's the best site? Well, there need to be where there the least impact on existing users of the region, where it will be cheapest to develop. So we have to consider factors like that. So existing solutions are already out there for site selection. There are already web-based data viewers out there. There are, as I say, these spatial data viewers on the web, such as Marine Scotland's NMPI service that we can see at the bottom of this slide. And these display and provide information on hundreds of layers of data which can be viewed spatially to see if they occur in or around a site of interest. We've also had consultancy firms that do site selection work. These companies use traditional methods, manually assessing suitability and feasibility based on multiple and separate unintegrated data sets and tools in their studies or decision support, and they operate on a per project or per client, per technology or per site basis. But we feel that something's still missing in this area, and as consultants ourselves, we know the time and cost associated with such studies and know from searching for data ourselves what data viewers can and can't do. For the few analysis tools we've seen online, there's a lack of spatial selectivity or a limit on the ways you can integrate data. They're often location or sector specific. They can be expensive and don't always make use of the latest data. And crucially, they don't allow the end user to use their own data. The tool also needs to offer transparency and flexibility to suit the needs of the end user. So the need for a tool, there's lots of people interested in being able to select a site. There's lots of need for a tool to be able to map out and display, but also understand the interactions between the data. So for example, an end user may ask, what are the determining factors driving a suitable site? What scale of development are you looking for? And is the scale in terms of installed capacity or the average power produced? There's so many questions that an end user might use that current tools don't offer that answer for. Just introducing the RADMAPP tool here. So as you can see from the slide there, we're taking account of technical, economical, social infrastructure issues, the spatial distribution using GIS sort of approach, and using scores to select the best sites. So when we're doing our work, all options need to be identified. We need to consider what barriers there are to development, typically technical factors that the development needs, This would eliminate the least suitable areas. We then identify acceptable and unacceptable levels of performance and costs, which provides a second screening level. And we can compare each of the remaining options to find the optimal site. At each decision-making stage, the potential for stakeholder and team engagement, and possibly even public consultation to feed into this process. So the key issues to consider in the site selection are the 5 main categories to consider when collecting the data. So we have the resources, which are things like wave, tide, wind, etc. Technical categories, seabed type, water depth, planning constraints, environmental designations, policies, costs and revenue, potential generation, distance from infrastructure, ports, grid, and the infrastructure itself in terms of the capacity of ports and roads to handle the development. So in terms of the energy resources, this slide shows examples of sources of data relating to the raw resource. Satellite data can give an indication of resource boundaries and surface features, but not subsurface. Buoys and ADCPs provide high level of detail for tide, even showing the conditions at the point in the water column device will sit. However, they're limited to a certain area. Multiple ADCPs may be required. There's also radar and other possibilities. We have the technical feasibility we need to consider. What are the maximum minimum water depths of the development, what foundation or mooring systems does the development need, the seabed type can affect the mooring type, the current velocity, is it resource for tile devices but a constraint for your wave device, how much tide can the device cope with. In terms of costs and revenue, I guess in the end the key factor for the developer always is going to be the profitability. It's a high cost approach, it's going to require a high revenue solution. And we come on to the planning constraints, shipping, fishing, seabirds, sea mammals, seabed communities, what level of impact is your development going to have on all these issues. Finally, the infrastructure. It's important to development. You need to ask, does it exist already? The tool will take account of the proximity to existing infrastructure. And does it have to be created, so you need to go through the same process to site this. The infrastructure may determine within the tool how important it is to where you site your development. So this slide here shows how the tool takes the data and ultimately works. So for each of the categories we've talked about, each will have numerous data sets within them. So for an area of interest, the tool would rasterize the data to the same format. So we may be working, if we're looking at a large area, at a 1 kilometre grid cell where every 1 kilometre cell covering a study area would have a piece of information relating to each of the sensitivities and technical constraints and costs associated with it. If we're looking more site-specific, that might come down to 100 metres or 10-metre resolution for the grid. So each data set is rasterized to that same resolution. This allows the user then to weight each aspect of each data set uniquely. For example, water depth can create custom depth bands and create a suitability weighting for each depth band. And each subset of each data set scored this way for each development type. So devices, cables, moorings, installation and maintenance operations, landfall, overhead lines, buried cables, the list goes on as to how this can be used to find the best sites, the different components of a development. So this slide just shows an example score sheet that is fed into the tool. So for each technology and each data category in the tool, we provide a front-end loaded score sheet of suitability scores. So you can see here there's just a few examples of the scores used within the tool for technical elements relating to a generic tidal device and a generic wave development. So as you can see in the last two columns, the scoring is on a 0 to 1 scale, where 0 acts as a constraint to the development, and 1 means there's absolutely no issues. So you can see that from the top or the top row for land C there, where obviously if you're looking for a wave or tile developments, land is going to be a constraint and is hence scored 0. In the C is not a problem, hence scored 1. Other categories, however, may not completely constrain a development, but within that category there may be attributes that are better suited to development than others. For example, if we look at the wave height category, we can see that smaller waves are better for a tile deployment in terms of survivability, but bigger waves conversely are better for a wave development in terms of generation potential. However, other than areas where there are virtually no waves, the score sheet is populated so that the tool can show some level of suitability for all the different bands of wave height that are fed into the model. The score sheet is not saying that development can't go ahead here, but rather that it would be better placed in larger wave environments than smaller ones in terms of the wave development. So we've previously discussed the different categories of data, technical, cost, planning, etc. And each data set within each of these categories would be scored in this way, depending on the technology you were considering. I think I mentioned quite early on about the need for transparency and robustness, and one of the key attributes of the RADMAPP tool is the ability of the end user to edit the score sheet. So a technology developer may want to alter the technical scoring factors after making some changes to the design. A consultation event may benefit from different C users applying scores that represent their interests, allowing various development scenarios to be contrasted and compared. However, a note of caution must be raised here. You don't want anyone completely unsupervised getting hold of the ability to edit the scores and spitting out a result that then states that Aquaterra recommends developing here when that's blatantly not the case. That's a brief overview of how the tool is used, and this slide just shows some history of how the tool has been used over the last, going back almost 30 years now. Starting off in the oil and gas sector, then moving into renewables, focusing primarily initially on Orkney in the early 2000s, spreading out to Scotland, other parts of the UK. So some of you recognise the Pacific Northwest coast there in the late 2000s as well, and as it's expanded, we've moved to different parts of the globe and have even done some large-scale suitability modelling of the entire globe. This slide just shows an example of the results of a RADMAPP process, and just gives you an example of what it would look like. So this shows the final results for a study into where it was best to locate a wave farm off Orkney. The green areas here show the most suitable sites, and the red areas the least suitable sites. With the blue C screened out areas, they're screened out due to total constraints. So, but even with these results presented after the combination of many multiple scored data sets, you can still see patterns of how individual layers have influenced the results. The northeast corner is less suitable due to the distance from existing infrastructure, which is more located towards the south of the study area. The areas in between the islands don't have any suitable wave resource, hence why they're constrained out. Missing chunk in the northwest is due to a skerry, where water depth rapidly decrease, and the very southern area is unsuitable for wave development due to very strong tidal streams. And on top of this, it's also possible to see the tracks of the vessels used as a layer for other sea users there that pass back and forth over often used routes in the area. So in terms of future possibilities, what are our next steps? We've often considered that this tool can be used for other development sites, not just renewables. In fact, wherever there's a question that needs answering that has spatially related issues, we feel that RADMAPP could be tweaked to that end use. We've delved into the development of other tools that could be linked to RADMAPP. And as I mentioned earlier, already strong links with the other tools that are going to be discussed today in terms of the underlying data. We've ventured into 3D modelling and visuals and hope to link the results of RADMAPP to show how a RADMAPP-derived scenario could look virtually. And overall, we want to improve the tool to allow the user full control over that decision-making process, whether that be a technology developer looking for the best sites, an environmental agency looking to see how development interacts with key sensitivities. And also now living in the 21st century, we want to get the tool online. So as I mentioned in one of the very first slides, we've had an ongoing relationship with Ocean Pixel based in Singapore. We first met up with Ocean Pixel like 5 years ago now and discovered that we were clearly interested in and motivated by similar objectives and were working on a similar parallel development of spatial tools. It was evident there were opportunities to pull together and collaborate our ideas, and funding through Nanyang Technological University allowed us to start advancing a web-based site selection tool based around the principles of RADMAPP, but also incorporating other attributes such as array placement and optimization, levelized cost of energy calculations, etc. So currently this is under development to provide a prototype tool for key tidal areas in Southeast Asia, and we're hoping this is the first step to an online global site selection tool. So finally, some quick conclusions about the tool is we're aiming to provide a tool that simplifies site selection, providing a complete suite of information, of data sets that are required to make a decision in terms of the development you're trying to find a site for. We want to make sure it's robust and transparent, and also allow the user to be able to score and change scores themselves to see how development scenarios may change depending on the suitability of different data types. We believe it's key to be able to export the results of the RADMAPP tool to be used with other GIS systems so they can be shared, and have the results underpin other tools elsewhere in the system. So I'll say thank you very much for taking the time to listen to me there, and just a reminder again about asking questions and to keep them coming in via the chat. And I'll now introduce Ian Hutchinson, who's a Director of Operations at Aquaterra. Ian has acted as the consents manager and license agent for a number of wave and tidal energy projects. This work has involved the production of a number of environmental assessments, HRAs, decommissioning plans and environmental mitigation and monitoring plans, requiring consultation and negotiation with regulators, agencies and stakeholders. As a consents manager, Ian has been responsible for the implementation and delivery of the EMMPs and discharge of consent conditions. As Director of Operations at Aquaterra, he leads the company's inputs into a number of strategic initiatives focused on better understanding, managing risk and reducing uncertainty around the potential impacts of wave and tidal energy projects on the marine environment. This has included recent work for the Scottish Government and the Crown Estate in the UK, as well as international bodies such as the US Department of Energy's Pacific Northwest National Laboratory. Ian currently sits on the European Commission's Ocean Energy Environment and Consenting Workstream Steering Group and is the Secretariat Project Manager for the UK's Offshore Renewables Joint Industry Programme, ORJIP, for ocean energy. Yep.
Thanks, Duncan. We'll just swap seats here at Aquaterra. So, good afternoon and good morning, everyone, depending on where you are. Duncan's already introduced Aquaterra, so I don't need to do that. So I'll just jump straight in. So, as Simon said earlier, I'm here today to discuss the impact assessment tool that we have developed for the Scottish Government. So just to give some background to the tool, this was built out a number of government-led drivers a number of years ago. So as people who are based here know, the Scottish Government set a target to cut carbon emissions by 42% by 2020. At the same time, they recognised the continued need to ensure the protection of our important biodiversity. And coupling these drivers with our strong aim to develop a sustainable marine energy sector in Scotland, they commissioned Aquaterra to undertake a project to review the potential impacts of wave and tidal energy developments in Scotland's meteorological environment. And this project ran over a number of years, starting about 4 or 5 years ago now. So the key aims of this project were twofold. Firstly, to evaluate the potential impacts of wave and tidal renewable energy devices, both wave and tidal, not looking at tidal lagoons or OTEC or the other ocean energy technologies, but focusing very much on the wave and tidal machines on Scotland's marine and coastal wildlife habitats. The second aim was to identify, prioritise and help address the potential key issues surrounding the developments of the sector. So not just looking at every possible impact, but really focusing on what we thought the key issues were. And the project only looked at ecological impacts. We didn't look at impacts in the human or physical environment. So this was very much a collaborative effort between a wide range of institutions, which included Aquaterra, the Sea Mammal Research Unit here in Scotland, EMEC, SAMS, the International Centre for Island Technology based here in Orkney, Aberdeen University, ERI, and Robert Gordon University as well. There was a number of key objectives that were set out during the project. The first of this was to identify the key technical elements associated with marine renewable energy development. So this included looking at the wave and tidal technologies themselves, the different mooring and anchor structures, and other support structures too, for example monopiles. And then we looked at identifying the marine species and habitats which were potentially vulnerable to the development of these types of projects. And we looked at marine birds, marine mammals, fish, and benthic habitats and species as well. The next objective was to then identify all the potential interactions and from those the priority marine ecological issues that could arise from the development of the sector in Scotland, and then to move on to provide recommendations and guidance for how to address these issues in the consenting process. So we had a good project steering group that was set up to help ensure that we met these objectives, and that consisted of the key sponsor, which was Marine Scotland, Scottish Natural Heritage, and the Crown Estate. There was a number of outputs from this project. These included a comprehensive database of all the potential interactions. I think this addressed between 40 and 50,000 interactions. We then undertook an assessment of each of these and identified an agreed list of key issues with the steering group and other key stakeholders. And then we produced guidance for how to consider each of these key issues in the consenting and planning process. So today I'm going to focus on the final output of the project, which was the impact tool itself. And this is an online tool to help provide direct access to the outputs of the study in an easily searchable and accessible format. So the tool itself can be found at this link, and I'm sure the slides will be made available online after the webinar, so you can access it through those. The main functions of the impact tool are to help people identify the potential key environmental impacts associated with different types of wave and tidal energy developments, and then to provide access to the guidance and recommendations as to how to best address these and how to best monitor and manage these during the consenting process and construction and operation as well. So this is the home page of the tool, and when you approach the home page, you can see that it provides links to introductory information, and this information really consists of a number of catalogues and guides. We have a catalogue which describes the relevant features of all the species and habitats that we considered during the assessment, and it also provides technical notes on the different technologies and the mooring classifications that we looked at during the study as well. So those are useful reference documents in their own right. It also includes a link, obviously, to the functional impact tool and to the assessment and monitoring guidance as well. So when you go into the Impact Assessment Tool tab, you can now query the enormous database that was created during the project. And you can use simple drop-down menus to select either the environmental pressure or impact mechanism that you're interested in, a species or habitat that you'd like to look at, or in this case, a particular technology type. We've selected a horizontal axis turbine here. When you then query the tool, it sets out a number of outputs that you can look at. So in this case, we're looking at a list of impacts that are relevant to the technology type that we selected, the horizontal axis turbine. And this page then provides a series of links which go to the summary of assessment results. You can also interrogate the very detailed assessment results that were produced by the project team. And then you can look at the relevant assessment and monitoring guidance in relation to each of the key issues that you can see listed here as well. So when you look at the summary results page, this page really just sets out an overview which provides an indication as to whether or not the project team assessed the impact as having the potential to be significant in relation to the technology type selected. It also produces a list of species and habitats which might be sensitive to the impact and should therefore be considered in the consenting or planning process. When you look at the more detailed assessment results, this sets out summary scores. So every impact was actually scored as to whether or not we thought it was significant, not significant, or if we didn't have enough information to make that assessment yet. There was then a clear explanation set out as to how the score was arrived at, and that provided a description of the impact and its potential effect on each of the relevant species and habitats, and that's text that can then be used by anyone undertaking impact assessments or preparing consent or scoping planning applications. And the value judgments provided here are transferable to other geographies and project types as well. The last tab then looks at the assessment and monitoring guidance that's provided in relation to each of the key issues that were identified during the project. And in this guidance, a series of outputs are provided. This includes recommendations and advice around the preliminary desk-based studies that would be required during the consenting process, any baseline characterization surveys that should be undertaken to gather the necessary data, and then any further desk-based studies that would look at that baseline characterization survey data that would inform the impact assessment process. And lastly, it provides possible monitoring and mitigation measures that can be applied during installation and operation, and importantly, suggestions as to under what circumstances each of these measures may become appropriate. And the plan for this information is that it can be used to facilitate discussions between developers, regulators, and other stakeholders to help define a proportionate approach to assessing and managing each of the impacts associated with a particular type of development. So in summary, the impact tool can provide the following: a list of potential impacts relevant to a particular type of wave or tidal project, a comprehensive overview of the potential effects of each of these impacts on a large range of species and habitats for marine mammals, fish, birds, and benthic habitats and species, and then guidance as to how these impacts can be addressed during the consenting and planning process. And a big part of this is that the tool can be used in the consultation with stakeholders at a very early stage around the planning, design, and consenting of these types of projects. Some other concluding points around the tool is that it's very much a demonstration of an impact mapping methodology that can be applied to other geographies, technologies, and project types, and that's very important when we're thinking about the transferability of lessons, experience, and data. It applies a risk-based approach to impact assessment, which is underpinned by evidence and, importantly, real experience of operating projects and technologies at sea. The framework provides a robust and transparent way to present this information, and the underlying framework approach that was taken allows new evidence and learning to be incorporated, which really helps future-proof the tool so that we can build off it as we learn more from the next set of projects. So that's all I'm going to say on the impact tool just now. So before I introduce Andrea, I should just maybe ask everybody to remember to keep putting your questions in the chat box, and we can have a look at those at the end. So moving on to Andrea. Andrea is the senior scientist at the Pacific Northwest National Laboratory. She joined PNNL's Marine Science Laboratory in Squim in 2006 as the Senior Program Manager for Marine and Coastal Waters. Andrea is the Research Lead for Marine and Hydrokinetic Energy Development and for Offshore Wind Development for PNNL on behalf of the US Department of Energy. Dr. Copping's projects focus on environmental impacts from the development of wave, tidal, offshore wind, ocean current and riverine energy installations, and the role that these effects could play in technology development and project initiation across the nation. Using risk-based approaches, the Marine and Hydrokinetic and Offshore Wind team, led by Dr. Copping, integrates laboratory, field and modelling measurements into a coherent body of evidence to support siting and permitting decisions. Dr. Copping works across several scientific disciplines to determine implications of human stressors on marine resources and ecosystem processes, working with stakeholder groups and resource managers to ensure that the available scientific information is accessible and achievable. Dr. Coffin is an affiliate faculty member of the School of Marine and Environmental Affairs, University of Washington, and associate editor of the Coastal Management Journal. So I think I'll just hand it back over to Simon now, or I don't need to.
No, I think
that's okay. Good.
Hi there. This is Andrea Coffin. Boy, that was a long introduction. Thank you, Ian. We'll have to shorten that one up. Thanks so much, and good afternoon, good morning. The third tool we are going to talk about today we've called management measures. And the purpose of this tool really is to help fill that gap. We have many interactions of potential risk of marine renewable energy devices with the environment. And we're not going to resolve all of those issues anytime soon. But in the meantime, we need to continue moving forward, both to ensure that we have an industry at some point, but also so we learn more. Once we get devices in the water, we can learn so much more about these interactions. So the purpose of this tool is to pull together what we know about potential ways to manage environmental effects. The reason we're doing this is we do believe that they will be useful in discussions that lead up to consenting or permitting and obtaining licenses. And having a developer and a regulator both have somewhat of the same sort of base of knowledge, we think really moves those discussions forward. In addition, we believe that some of these management measures may be useful to developers themselves in writing operational plans. What is the best way to go about designing, installing, and operating devices so that the environmental footprint is minimized? We have organized this tool by potential impact, by technology type, by interaction, and so on. And what I want to do today is just give you a little flavor of that tool and invite you to come along and try for yourself. So in order to create this tool, this goes back to the need to gather these management measures that have been tried. And we scanned through applications and licenses in the UK and elsewhere to see what kind of measures have been used or suggested. We consulted broadly with researchers and regulators. We collated these management measures and parsed them by technology type, wave, tidal, or both, by the phase of the project. By design, we need any engineering or a construction that might be put together prior to going in the water, through installation phases, operation, maintenance, decommissioning. We organize them by the stressor and receptor interactions that we have talked about under Annex 4 and other programs for some time, the typical risk to animals from colliding with a turbine blade, effects of electromagnetic fields or underwater noise on animals, benthic habitat effects, etc. And the typical receptors are those we are concerned about in the environment: marine mammals, fish, birds, habitat, etc. We pulled together the management measures, and in each case, we have provided a brief analysis of the implication of using that measure. Some cases, whether it appears to be effective, in some cases, what the upsides and downsides of using that measure might be. Okay, the way this came about, in February of 2016, we, Annex 4 and others, pulled a workshop together in Scotland where we invited researchers, regulators, developers, and consultants who are focused on the collision risk of animals with tidal turbines, this still being one of the top environmental interactions of concern. And out of that workshop, we developed a plan that would help move towards retiring that risk, making that a manageable risk. And one of those recommendations out of that plan was the need to collate, to analyze, and to disseminate management measures that can and have been used. For those of you in the UK and Europe, you will find this is a called-for measure in the UK ORGEC Forward Look. And we brought this information together at a workshop in Glasgow in Scotland last May on management measures. What we did was draft a set of these measures together. It's really a big set of spreadsheets, and sent them out to invited participants ahead of time. Again, those participants included representatives of the research community, development community, and regulators. These topics were discussed topic by topic at the workshop. We iterated with the participants and with a broader range of interested parties, and then we built this into an online tool. And what I'm going to spend the rest of my time here doing is walking you through that tool as an example of what we think can be done with it. Okay, so I'm hoping many of you are, in fact, familiar with Tethys, tethys.pnnl.gov. This is our online knowledge management tool that collates so much information from journal papers, reports, other media, etc. And I think you could say we're really trying to move beyond just the collation of material to really be able to say a little more through analysis and presentation of how these materials can be used in a practical manner in developing marine renewables. So here's the front page of Tethys, and if we were to go up to the menu under Tethys Content with a drop-down menu, you'll see that you can choose the Management Measures tool. So we'll choose that. And this is what you see when you pull it up. A very familiar looking page from Tethys for those of you who use it. It is a description of why we have this Management Measures tool, and it explains how the tool can be used. And what you will see in this line of boxes about halfway down where the little arrow is, you will see a series of drop-down boxes that allow you to filter the far left by technology type, next by management measure category, and you'll see that in a minute, project phase of the project, then the stressor and the receptor. And then the very familiar looking table underneath for those of you who use Tethys, but instead of consisting of documents, this consists of the output of a management measure tool. Now, as I mentioned, much of this information was gathered together in spreadsheets, and there are quite a number of spreadsheets on the back end of this tool. This is how the tool is run, and this allows us, as we get updated information, as we get new information, to readily update the outputs. Okay, so we're going to go ahead and we're going to decide to look at management measures for tidal energy. So we choose the technology type tide. We are going to decide to examine collision risk. We go up to the stressor and choose collision risk. And we'll look at collision risk for marine mammals. So we go to our receptor and choose marine mammals. And we're going to look particularly at those management measures that apply to the design stage. This is implementing engineering or other solutions before going in the water. So that's where we go up to the management measure category. And finally, this is what the outcome of those choices look like. This was tidal, collision risk for marine mammals, and what can be done in design phase. And what you see here is a list of 3 management measures. If you go to the second to right column, you will see the 3 management measures there that can be done beforehand. The first involves adding an acoustic deterrent device to the tidal turbine or the base that will help to keep marine mammals away. This will be most useful in, say, things like seals. And we've discussed a little bit what that's likely to be. It's a reasonably inexpensive solution, but will have to be incorporated into the deployment and operation. The second management measure includes installing a detection and shutdown system. Now, this is a great deal more difficult technically, considerably more expensive both to install and to operate. But we do see this kind of management measure being explored and requested by regulators. If you could, in fact, effectively detect every marine mammal that got extremely close to a turbine and shut the turbine down, very much as was done with the MC turbine in Stratford Lock, you could clearly reduce the risk of marine mammal collision. But there is an extensive cost both in technical development, operation, and loss of power. The third management measure is a bit of a hybrid of those two, and that is one would install an acoustic deterrent device to help keep animals away, but then as a final backup, a detection and shutdown system. Obviously, you would detect, if you kept the animals away, you'd detect fewer, but this still clearly will be quite a complex system, an expensive system, and also you have the additional problem of having acoustic output, additional electromagnetic energy floating around while you're trying to detect. So there are significant issues here. One thing I want to note on this page and all others like it, if you go down to the bottom, there's an easy feature to export this information into an Excel spreadsheet or other CSV format. So that's basically what the Management Measures tool looks like. I'll just give you a couple of other examples. This particular one has already been filtered down. Here we chose the wave technology. We looked at it during installation and looked at the different kinds of management measures that might be possible. Our receptor of concern were benthic communities, and the stressor is obviously as you install a wave device, whether it's putting in anchors or might be a bottom-mounted device, cable lay, et cetera, you would disturb habitat and perhaps lose some habitat. So when we filtered this down, what we found was 4 management measures that had to do a good deal with how you avoid this loss of habitat. The first one is obviously micrositing, careful siting to avoid rare habitats, particularly, let's say you're in a very large soft bottom habitat area with some small amounts of hard habitat, reefs, say, you would want to avoid those. And again, this is something that can be done right up front in siting. Again, when siting and organizing the actual installation, the second design, the management measure, is simply minimizing the footprint of anchors and foundations. And this obviously, again, creates less loss of habitat. The last 2 measures deal with cable installation. Now, in planning, if the cable management measures, protection measures can be minimized, that you will again destroy less habitat. Or in terms of mitigation, perhaps you could use locally sourced materials as that cable protection. For example, if you need hard, like protection of the cable, mattresses and so on, would it be possible to source local rock, which then provides the same habitat for benthic organisms to attach to? Or if you were in soft bottom habitat, obviously if you bury a cable, you are burying it with the local sediment. So these are just some things to think about. In most cases, these ones are, again, before the device goes in the water as part of the design phase. One more example, in this case, again, we chose wave during operations and maintenance phase of the project. And the management category we're looking at is monitoring. Obviously, that most devices and single and arrays that go in the water these days, there is some requirement for monitoring. In this case, we're going to look at the fish as being the receptor of concern and multiple different stressors. And for example, on the first line management measure, we're concerned about underwater noise affecting fish. And the very obvious management measures is to measure the sound output from your device and get some sense of whether the amplitude and the frequency of those wave particles associated with that sound are within the hearing range of the fish of concern. So that's one, again, that can be designed ahead of time. If the concern is about collision risk of fish with turbines, this is another tough one where we need to have better research and really to understand what the interaction of those fish might be. If the worry is a floating wave device with mooring lines and worry about entanglement of large fish, such as basking shark, there is an important issue, not so much with entanglement of the lines, but with lost fishing gear, perhaps acting as derelict nets and catching fish. And understanding what fish are in the area, how that can be minimized, whether there's the inspection of mooring lines to ensure that fishing gear is not present and causing harm. These are the kinds of management measures that you will find in this tool. This is just sort of a smattering of a few that you might look at. And that's really the tool. So, just to summarize here, we see this tool as being useful in managing potential effects. It allows for some predetermination, some prediction of what might be asked of developers, to provide a forum for discussion between developers and regulators when having worked through such things as the impact tool that Ian talked about. There's some identification of potential impacts. This is a way to try to manage them. We think that the developers may be able to incorporate some of these ideas into operational plans as well. For example, if a developer is asked to examine potential effects of electromagnetic emissions from an operational turbine, there might be a need to monitor what those EMF emissions might be. But this fits extremely well with health monitoring for the turbine. One would want to look at the electrical emissions and see how they're changing from that turbine in any case. So we see this as a way to really look ahead, minimize costs, maximize protection of the environment. So with that, we are really looking for you to use this tool. We're looking for feedback. It's just been hooked up on Tethys in the last few days. So please go in, see if you can mess around with it, give us feedback, tell us what you found useful, and tell us if you find things that are either missing or wrong. Okay, with that, I just want to acknowledge my team here, Annex 4 team here at BNNL, and of course the many, many countries, developers, regulators that help us get where we are. And with that, I think I turn it back to Simon to field questions. Let's see, I have to stop sharing. Hold on, and give this back to Simon.
Great. Thank you, Andrea. Let me just get to my last slide here, if possible, because the first question was, where do I find this webinar? Where is this archived? And I want to just get to the last slide here, which might take a second. So for those of you who would like to download this later or share it with your friends and colleagues, this webinar is being recorded and archived, and like all of the Annex 4 webinars, you can find it on the Tethys database, and you can see the link right there at the top, tethys.pnl.gov, and then other words to follow. And you are probably all on the webinar mailing list for Tethys and Annex 4, so that's a source where periodically you'll see what the next webinar is going to be. And if you're not on the webinar mailing list, you can see a link right there to get on it. And hopefully that answers that first question, how do I access or how do I download this content? The second question that came up was a question for Ian, and I am going to, I see a number of questions coming in now, which is great. Ian, and I'll also expand this to the other participants as well, am I correct to assume that the impact tool is only relevant to Scotland at this time? And if so, do you have any plans to collect databases relevant to the United States? And so, Ian, I'll let you start with that question, but maybe other panelists consider how do you, when you're developing or designing a tool, how do you get appropriate local resolution so that your tool is useful at the intended level, but also designed for expansion to other places? So maybe, Ian, specific to impact, you can go first.
Yeah, thanks for that, Simon. So yes, the impact tool was originally focused on the Scottish environment, but the way that the tool was set up was in such a way that we could make it as useful as possible, not just in Scotland, but around the world. So rather than just looking at the potential effects on Scottish habitats and species, we kind of split the assessment in two parts. So we really looked at all the different technologies and support structures and their ability to give rise to a particular impact mechanism. So a technology's ability to give rise to an impact mechanism, be it noise or collision risk, that information is entirely transferable. What we then did was take a long list of Scottish habitats and species and look at their sensitivity to those impact mechanisms that could be applied by the technologies. So whilst that's more relevant to Scotland, obviously a lot of it is transferable when we're thinking about the impacts of, acoustics generated during this project on different marine mammal species. Yes, there's going to be nuances in how that assessment results are applied depending on the precise species you're looking at, but I think a lot of the information is transferable. So to wrap up on that, I think the information regarding the impact mechanisms is completely transferable, and even some of the ecological assessment would be as well. In terms of plans for expanding that out, that is something that we are very interested in looking at a European and a global level as well. So those are kind of active and ongoing discussions, because we think that this tool, actually in combination with the other tools that we've looked at today, could be widely applicable for the whole sector.
Yeah, Simon, this is Andrea. Ian is exactly right about that. Scotland was fortunate to be able to really focus in on this sort of thing and has a lot of really detailed information. And as we looked at the impact tool in developing the management tool, and I should say Aquaterra has been our very, very strong partner in this management tool, not on behalf of Annex 4. We have talked about how we might look at the impact tool and make it more generic or make it more specific to the U.S. and to other countries. We're certainly open to that idea. I will note that the reason that impact tool is so effective in Scotland is they have a great deal more data. They have a great deal more to go on than we really do. So it's sort of a cart and a horse. You need more in the water data collected to be able to do that effectively.
Great. And Duncan, I don't know if you have any thoughts on RADMAPP beyond that, but I think that's really helpful. Thank you. The next,
Ian,
go ahead, Duncan.
No, I was just going to say, I think Ian and Andrea have covered that there, so that's all fine.
Okay, great. So we had a question coming in about monitoring data. And the question refers to a report coming out of the UK reviewing offshore wind monitoring data, concluding that it might be of limited use as methodologies vary. So maybe the limited use to apply to other sites as methodologies vary. The question is, could these online tools also incorporate recommended monitoring methodologies to aid comparable data collection from different developments, I guess, to apply to other developments beyond where that data where those data were collected? So maybe Andrea, I'll aim that one at you at first. So the idea of applying data from one site to other sites and how tools might be able to help with that.
Oh, thanks, Simon. What a wonderful question. This is obviously the really important thing we're all trying to get at. And under Annex 4, so nothing we've talked about today, but under Annex 4, we are undertaking for this year this whole issue of data transferability and collection consistency. How do we examine data sets from one place and use them in another location, perhaps as much as halfway around the world? And we are trying to really understand from other industries how this is done and set some criteria, some methodology to achieve that. And one very key part of that is while data don't have to be collected by exactly the same instrument or exactly the same protocol, there has to be comparability. And so we found that's not always or often the case. So we are really trying to set some sort of balance on that as well. And as part of that process, after the first of the year, we are enlisting regulators in particular who will sit down with us, look at data sets, and help us explore what the limits of that transferability and collection consistency might be, what really works for you under your permitting process, what doesn't work. Because I think until we get to this, it's going to be very difficult. And I'm very aware of that MMO report out of the UK on offshore wind, and I think it sobered a lot of us up to realize how many millions of pounds had been spent without an awful lot to show for it. So very much where we're trying to go to with Annex 4.
Duncan or Ian, do you guys have any thoughts on that question as well?
Yeah, I'll just add to that. I mean, I completely agree with what Andrea said, and what I should say is that the assessment and monitoring guidance section of the Impact Tool website does include exactly that. It looks at what data should be gathered to help inform assessments of each particular key issue. Which is a really important point, because I think before anybody goes offshore and starts to gather data, they really need to think about the questions that they're trying to answer, and I think that's probably one of the key lessons we can learn from the report that's referred to and the experience of the offshore wind industry, particularly around any large-scale baseline data sets that people might be asked to gather, to really think about how that's then used and inform decision-making and the consenting and planning process. So although there's some high-level guidance already in the Impact Tool, that's really something that I think that we can collectively improve on through programs like Annex 4 and Ocean Energy as well.
Excellent. Duncan, a question for you, and then we can also, this is sort of a pretty quick one. Is Aquaterra's RADMAPP an open source free tool? And so I'll ask you that question first, and then Andrea and Ian, you can also answer that question for your respective tools.
Thanks, Simon. No, it's not open source and free. The RADMAPP tool up till to date has been almost developed for a client's needs, and it's had to be funded for development. The Aquapixel tool I discussed at the end is going to hopefully have free elements to it. It's not going to be completely open source and free, but once we get it up on the web, then it will be available for users to be able to access and view data and look at certain aspects of the analysis, but to be able to get into the real guts of the analysis work and the real power of the tool, then that will be a fee-related service.
Great, thank you. Thank you, Andrea and Ian. Similar questions on management measures and impact. Are they open source or freely available, or how do you get them into people's hands?
So in terms of the Impact tool, Simon, that is available on the Marine Scotland website through the link that's in the slides that I presented earlier. In addition to that, there are vast volumes of information that help underpin the assessment that was undertaken. The kind of 40 to 50,000 interactions are all described, and if anybody would like access to that, they can contact us directly as well.
And management measures, as I showed you, is on Tethys, and everything on Tethys is always free and open.
Great. First of all, I want to thank the audience here. We're getting good questions coming in. These are all your questions, and if you have more questions, please keep them coming. I still have a few more left to get to. So this one is for Ian on impact, and how often is the impact tool updated with new information and evidence?
Excellent question. So it's already been updated once, about 2.5 years ago, was when it was last done. There's no immediate plans to update the content just now, but we'd be interested to do that. And I think as we see more experience and learning coming from real projects at some of the test sites and the first arrays, we'll be looking for opportunities to get that work done.
Great, thank you. And I'm guessing all of you are interested in working with stakeholders and others to make sure that you have the most up-to-date information. And maybe I'll just ask a question of my own on that one. How do you do that? How do you incorporate stakeholder or audience input or guidance into the design phase of tool development? Is that something that you set out from the beginning, or how does that work? And maybe I'll just start out with Duncan, and then we'll go down the list.
Sorry, Sam, are you able to repeat the question there?
How do you work with stakeholders and your intended audience up front, or do you work with your intended audience while you're in the design phase of your tool?
I'd say the most interaction we have with the stakeholders and the intended audience is mainly when we're using the tool as a way of community engagement, say, or stakeholder engagement. So I won't say it's particularly in the design of the tool, although certain elements with the new AquaPixel tool may well have interactions with stakeholders, because we intend it to be used not just by developers of technologies. It is intended to be used by regulators and environmental agencies to help determine applications, etc. But normally it's at a stage where we're able to show them and let them tweak scores and put new ideas into it to get answers out that help make their decisions easier.
Thanks for that. Ian, maybe same question to you. With Impact, do you build in that interaction with your intended audience up front, or is that something that you use further down the line?
Yeah, absolutely. I mean, the core sponsor was the Scottish Government and Marine Scotland, so we had representatives from the licensing and policy teams involved in scoping out and designing the project and the tool, and as well as feeding in information the whole way through. We also had the Crown Estate, who manages the leasing system here in the UK, and also Scottish Natural Heritage, who are the statutory environmental advisors. So they were involved every step of the way as a steering group. Obviously, the project team itself was included quite a broad range of expertise that had been involved in the development of the sector. But we also had a application process where we bounced the results off developers and other environmental stakeholders to really test run the tool itself, more importantly to see what people thought of the content and the decisions that we'd made. So yeah, very integrated process as far as the stakeholder involvement goes.
Thank you. Andrea, do you have any thoughts on that?
Duncan and Ian have really said it properly. You have to have just the nature of these tools. They are very much embedded in the community, regulators, developers, researchers, and I think we've developed all of them with them in mind. But I do want to underscore something Duncan said. You can't just go to a stakeholder group and say, what do you think this ought to look like? In every case, and I mentioned the various workshops we had gone through, it's really important that you get something sort of on paper for people to react around. And we've done, through Annex 4, with strong support from Aquaterra, we've done quite a number of these workshops. And I think we've got it down where we've been able to both engage the right stakeholders because they believe they'll be spending their time wisely through the day, but also make sure that there is significant information for that group to react to ahead of time. And then iterate with them, iterate with the larger community. Yeah, I think it's effective, but if you try to do it in a dark, smoke-filled room, it doesn't work.
Thank you for that. Another question here from the audience. How often, for the management measures tool, so Andrea, is there a threshold for when a management measure may no longer be suitable?
Boy, what an interesting question. We need to be careful that what we have as management measures tools, management measures listed in this tool at the moment, some have been tried, some have not. Some are recommendations by regulators or suggestions from the research community. And I think we need to be able to, among other things, start to prove some of these as useful or not. But I think absolutely there are some where the management measure tool may become unnecessary. It may be found to not fit properly. We had a lot of debate early on whether to include some management measures that had been suggested early on in the industry, but since rejected. Let me give you examples. Are different colored lights or flashing lights useful underwater with turbines to keep animals from colliding? And it was determined probably not. Similarly, painting blades different colors. These are the kinds of things that probably from the best we can glean from behaviorists, these are not going to have any effect. So we've tried to already sort of narrow them down to ones we think are most likely, but they really do need testing.
Great, thank you for that. I am getting down to my last couple of questions, so if you're in the audience and you're just sitting on a question that you really want to put out there, please put it out there now. Otherwise, I'm going to ask this question, and then I'm going to ask the panelists if they have any final thoughts before we say thank you and sign off here. So if you have a burning question, and one just came in, please ask it now. So while I digest the question that just came in, I will throw this one at you guys. Can these tools be used together? Are they complementary? Can they be used together by developers, or are they sort of separate efforts that are aimed at answering very specific questions?
I don't know.
Yeah, go ahead, Andrea. You take that one.
Oh, sorry. I was just going to say, great question, and I'm sorry that we didn't say that up front. When we thought about these tools and developing them, and also this webinar, quite honestly, we realized that starting with RADMAPP to help with siting, impact will help the developer and the regulator have that conversation around what are potential impacts, and then the management measures tools will help with that conversation about what to do with those impacts. So we see these three tools as very much a continuum, helping to fill in the spaces that are needed.
I think that's great, and I think I'll ask the next question, Ian and Duncan. I think, Andrea, you got that one well. So this one is for Ian. And the question is, for regulators and developers to gain confidence in using impact outside of Scotland, it would help to have examples of where it's been used successfully. So are there any specific examples of projects in Scotland or elsewhere where this tool has been used to inform an EIA or environmental consenting process, where all stakeholders have been comfortable with the outputs? So I'll ask that first. Do you have any good examples of successful use of the tool?
Yes, absolutely, Simon. So obviously a key part of our work here at Aquaterra is environmental impact assessments and the relevant planning applications. So we use it in all of our projects, but as far as I'm aware, it's used regularly within the licensing and advisory teams within the government departments here as well. It's been used for most array applications, as far as I'm aware, to some degree, to inform the initial discussions with stakeholders. The way the impact is set up at the moment is it's very much designed so that it gives you a starting point for discussion, a long list of impacts that are relevant to your project. You can start to scope things out, but the content is set out in such a way that you can effectively use it to undertake an environmental scoping exercise, to not only give you the list of impacts that you do want to look at in relation to your application, but also don't, and it gives enough detail as to why you can start to scope things out. Another clear example is that the impact tool and the list of key issues that were produced during the study were used to underpin the Scottish Government deploy a survey, deploy and monitor strategy. Anybody who's looked at the content of that and the key outputs of the impact tool will see that they're essentially the same lists with a few additional things thrown into the survey, deploy and monitor strategy. So yeah, it's been used strategically and at a project level here, and actually in other places too. We've never prepared detailed case studies, but that's definitely something that we could possibly do if we move to a new phase, just to show that it is being used. It's also referenced in a number of EIAs and applications for anybody who's read those.
Great. That's a great answer to a good question, and that is the last question that I have from our audience, and it's about 9:20. And maybe what I'll do for the last few minutes is just see, Duncan, Ian, Andrea, do you guys have any final thoughts or thoughts that came up during the question and answer that you wanted to bring up for the audience? I'm not going to sit there and call on you, but anything you want to raise just before we close out?
Simon, this is Andrea. It seems like there's a lot of interest in sort of, questioning and burrowing into these sort of tools a little bit, and particularly how they might be applicable further away. And that, as I said about data transferability, I consider that one of the big questions we're facing right now. I would like to invite any regulators or those who are, resource managers, consultants to regulators, et cetera, to join us in really trying to burrow into this in this data transferability process. So if you have an interest in these kinds of things, and some of the questions we saw were great, please drop me an email, and my email is on that final slide up there, andrea@nnl.gov, because we'd really like to have you, the participants in this community, be the ones to help to drive this. Thank you.
Thanks, Andrea. Ian or Duncan, any final thoughts?
Yeah, just one point I think for me, Simon, just coming back to something that Andrea said and kind of carts and horses. We developed the first version of the impact tool quite a number of years ago. I think the actual first project started off in maybe 2011 or 12, so we didn't really have a lot of data then, but we were able to do a lot with what we had. And I think now that we're starting to see more projects in the water and more real data coming forward, I think the importance of tools like these to manage information, transfer data is going to become even more heightened, and as more data becomes available, then hopefully we can use them to help streamline the process of consenting and planning even more, because as more projects go in, the sheer volume of data that's going to be generated from individual projects is going to be vast, so we want to make sure that we make the most of it.
Excellent. Duncan, I don't know if you have any final thoughts?
Yeah, just coming back to the data again, I was just thinking then about how my involvement with the site selection work has gone back over probably 10 years now, and being involved with searching for data for certain sites, and even now branching out into new areas of the globe, how difficult it is to get hold of good data. And you've probably seen from the presentation, the way the RADMAPP tool works is it's only as good as the data it's built on. So there are issues, as has been discussed, with data, where it comes from, how transparent and robust it is. So there's a real need for getting uniform data into these tools. But where it doesn't exist, we still have to have that ability to look for maybe for surrogate data or work with what we've got and still produce a useful output for the client.
Great. Well, with that, I would like to thank you all for great presentations, and I think a really good question and answer session as well. The last slide that's up there, again, this webinar will be archived. It'll be downloadable. You can find it on Tethys. And obviously be looking for Tethys Blast and other announcements on future webinars. You can see where to get a hold of the PNNL team there with all of our email addresses. Duncan and Ian, do you guys have a preferred way for people to get a hold of you?
Personally, I'm happy email. I don't know if our email addresses are up on the slides anywhere. Whether we can get those out, I don't know.
They can find you on your website, though, correct?
Yeah, they can, Simon, and maybe we'll get our emails added up to the slides that are uploaded too.
That sounds like a good plan. Okay, and with that, thank you very much. Jordan, do you have any final comments before we close the webinar?
No, I do not.
Okay, and so ends this webinar. Thank you all, and please do get in touch with any remaining questions, and please do visit us and download the webinar and share it with your friends and colleagues. Thank you very much.
Thank you for joining today's conference. The session is now concluded, and you may disconnect.